Hi, I'm Mr. Franklin, and today we're going to take a look at the next part of our energy discussion, which is kinetic energy. So we've talked about mechanical energy, light energy, radiation energy. We got really into specifics with gravitational potential energy. Today we're going to talk about kinetic energy. So kinetic energy is the energy of moving things, of motion. So a moving object, so we're going to do the whole insert our other definition here. A moving object has the ability to generate a force over a distance. It has the ability to do work. Okay? So energy always has the ability to do work. And if you think about it, a great example I like to think of, you got a football player. If he's moving and he hits someone, his energy of motion can be translated into, so we've got our football player, okay, and they're running, and they hit someone, they can apply a force over some distance because of their motion, okay? And that would, so before is going to be the energy, kinetic energy, which we're going to use the letter K. After, it would be work while they're actually doing the force over a distance. Okay? So the symbol for kinetic energy is the letter K. It's a capital letter. And our equation is K equals 1/2 mv squared. Now that's how it's most often written. On your equation sheet, they write the half like this. And a lot of people confuse what's going on. If we're going to be really technical, it should probably be written like this. Because when we write the letter 2, when we go back to like early second, first grade, third grade fractions, it's the same as writing 2 divided by 1. So we could say m is the same as m divided by 1. So I know I'm probably spending way too much time on that, but the important thing is when you're doing your calculator, kind of follow your PEMDAS, exponents, okay, then multiply, and then what you're going to do is you're going to divide by 2. So in your calculator, you're actually going to go V times V in your calculator. Depending on your calculator, there are other ways to do it. But V times itself, and then you're going to multiply it times mass, and then you're going to hit the divide button and by 2. That's your calculator if you're doing a basic scientific calculator. You can also do some x squared and hit some other fancy buttons, but many of you will mess that up. So this is a sure way to get the right answer every time. V squared times m divided by 2. But we're going to write and say the equation like this. Okay? Alright, we'll practice in just a second, so you'll see what I'm talking about. Oh, here we go. Calculating kinetic energy. So our first example problem, we have a car with a mass of 1,500 kilograms moving at 20 meters per second. What is its kinetic energy? So we've drawn our picture and we've labeled our stuff, and now we're going to do our KUF. So our knowns, we know the mass is 1,500 kilograms, we know the velocity is 20 meters per second, and we're looking for kinetic energy. The formula is 1/2 mv squared, and now I'm going to plug it in. 1/2 mv squared. Plug in our numbers. What's our mass? 1,500. Our velocity is 20 meters per second. That's kilograms. And that's squared. So on my calculator, I'm going to go 20 times 20, which is 400, times 1,500. So 400 times 1,500, that's 60. And then 1, 2, 3, 4, 600,000 times 1/2. And that's 300,000. Pardon me. 300,000. So half of 600,000 is 300,000. And it is still energy, so the units is still joules. I hit my button. Joules.